All right, this one goes out to Bella because she said, yo, Mr. Bass, you don't even sing anymore. Oh, I'm going to sing, Bella. This is what's happening. Because I got to give the people... Get the people what they want. They even threw a little beatbox in there. That was for you, Bella. All right, so... if you are in my class, Mr. Bass's class, you're not going to have to write all of these notes because we did some of it in class already. You really only need to write the notes up to the B value because that's the only one that we haven't talked about. If you are in Mr. Tillis's class, I believe you haven't written any of these notes yet, so I would get them all down. All right, trig transformations. We're going to talk about how you transform both sine and cosine. You saw a little bit of this. We did some explorations with this on Desmos, and now we're just going to solidify it so you have it in your notebooks. All right, so go ahead and write down this equation. Y equals A times the sine of bx minus h plus k. All right, these transformations are basically the same as the transformations that you've seen on all the other functions with exception of this b value. So I'm going to go ahead and start off with this b value. So again, if you're in my class, you definitely want to get this part down. The b value. The b value changes the period, all right? It changes how fast it does the full cycle. It makes the entire cycle happen faster or slower. So please draw both of these... what are these things called? Both of these sine waves that we have right here. Notice in this first one, this is a regular sine wave. This is y equals the sine of x. It has the regular period of 2 pi, right? We can see the period goes from here to here, and it's at this point that the pattern starts to repeat itself. So that period is 2 pi. But now if we look at this other one over here, I have the same graph from 0 to 2 pi, but notice this one is the sine of 2x. So notice it makes this circle do its cycle twice as fast. So instead of it taking 2 pi, it does the whole period in just pi, okay? So this makes the period actually shorter because it happens faster. So notice, right, this period now happens in half the time because it's going at basically twice the speed. Okay. Now for Mr. Tillis's class, I want you to make sure you get the rest of these. My class, you're welcome to write them down, but I know that you have this, or you should have this in your notes already, unless you miss class. If you miss class, get it down. The A value, so going back up here, this A value, we know what A values do. This A value changes the amplitude, okay? So it basically gives me a stretch or a compression of the graph. So notice I'm from 0 to 2 pi, right? My period is the same when I do y equals 2 times the sine of x. But notice now, instead of going just to 1, like in the unit circle up here that goes from 1 to negative 1, since my A value is 2, I changed the radius basically of that unit circle. Everything that was 1 is now doubled. So this now goes up to 2. So the amplitude is 2 on each side instead of just 1. All right. Finally, these are the most similar to what we had before, so I'm not going to talk too much about them. H and K. H is the thing that shifts left and right. Remember that it is the opposite for H, right? So if I have x minus 6, it actually shifts 6 to the minus 6 would be to the left, but since it's the opposite, it shifts 6 to the right, okay? And K gives me that shift up and down, and this is not the opposite. So if I have sine of x plus 4, that's going to shift up 4 spaces. All right, those are your notes today. Nice and quick. Hopefully you all had a great weekend, and I will see you on Monday.